Greetings and welcome to the UC San Diego AI Alumni Council webinar series. Today, we focus on student spotlights. For context, every quarter, we feature very distinct perspectives on how AI is shaping our world. And we start each quarter with AI Meets Life, which we find surprising and not the headline ways, but inspiring ways that AI is already changing how we live and work, but is not obvious to us. Then the second month of every quarter, we feature student spotlights, and that's what we're focusing on today. I'm excited about the lineup that we have for you. And then the third month of every quarter, we do industry ROI, and these are real companies, real outcomes. Our first one, we had 10 case studies. Our next one is going to be a single focus company, more of a deep dive. Today, we will start with some updates, and then we feature 4 student teams presenting their projects across a range of topics in AI technologies. So today's projects span the use of AI in smart waste tracking, education and learning, environmental ecosystems, and even financial markets. Among the AI technologies used, you'll see machine learning, computer vision, IoT, AI workflows, RAG, and something that's cutting edge and causing a lot of angst in industry, multi-agent simulations. So we're looking forward to seeing all these. These students are presenting right in the middle of midterms. So thanks to all of you. We have 11 students here today. Thank you for your commitment to your projects and for sharing with us. And I do hope to have time for Q&A. So just a quick housekeeping note. First of all, we are recording this, so all attendees will receive the recording and the slides. I hope we have time for Q&A at the end. So if you have questions, if you move your cursor in Zoom, there's a little window that'll pop up with Q&A. If you don't see Q&A, there's the ... menu, and you can enter your questions there. If you have questions for specific student projects, enter them. We'll get to them at the end of each student presentation. Unless we're running a little late, then we'll try to get to them at the end. All right, so I will hand it over to Brian for updates.
Hey everyone, I'm Brian. I'm the co-chair of the AI Alumni Council, and I'm here just to give you a couple updates before the students get going. So in June, we have Sidearm Sports coming to talk. They're going to talk about ROI of AI. Specifically, they're moving their company over to an AI forward, an AI focused company. So they're going to talk a lot about what it took to get their workers up to speed on AI, using AI, and how they're using AI to enhance the work that they're doing and be more productive. We also want to go over the survey results from the survey that you all filled out. Thank you for doing that, those who did. We'll talk about what the second half of the year is going to focus on. And then in July, we have another AI Meets Life episode, Handshake and Databricks. So this is going to be basically a new business model that Handshake and Databricks have created. We're going to look under the hood at how they're doing their work with frontier models and how the human expertise fits into the loop. And then also just what the reliability and the AI looks like in practice. So we'll hear a little bit more about what they're doing and how they're doing it. Sandra, I don't know if you want to add anything there, but that's my quick summary.
No, that sounds great. I'm looking forward to those sessions.
Great. So as usual, we want to hear from you. Scan the QR code or find us on LinkedIn, the AI Alumni Group. Most of this stuff can be found there. We are also on Instagram, and you can register for any of our webinars at this QR code, as well as we have an email list if you want to join that. But yeah, basically interact with us in any ways you can. If you're not sure how to do, find me on LinkedIn. I can help you get there. I want you to have the information and be able to use it. Also, if you want to become a speaker, we're always looking for speakers for these webinars, as well as some of the other tracks we have going. So you can submit a form. It's pretty short and sweet to the executive committee, and you can do that through this QR code at this link as well. And this is the leadership team, as we always show. If you need anything, find one of us on LinkedIn or reach out. We're happy to chat and figure out how to direct you where you need to go.
And just to add to that, thank you, Brian. It's hard to keep track of who's on the leadership team. I don't expect you to remember all this, but if you go to the LinkedIn group for the UCSD AI Alumni Council, all of us are on there as managers. You can click on any one of us, reach out to us by DM, connect with us, and we encourage that. Okay, thank you, Brian. Our first project applies AI and computer vision to a very practical operational challenge, waste management and sustainability. Daniel Matthews and team will present CarbinWatcher, which is a smart waste tracking system that combines computer vision, sensors, and cloud analytics to classify waste, monitor fill levels, and provide facilities teams with real-time operational insights. This project was originally developed at a UCSD hackathon where it won multiple awards before evolving into a larger initiative. Daniel, over to you and team for brief introductions and CarbinWatcher.
Hey everyone, we're CarbinWatcher. I'm Omkar, a freshman computer science major with interest in computer vision, natural language processing, and edge AI. I'm open to working this summer. This is Karsten.
My name's Karsten. I'm a data science student, also a first year, UCSD. I'm interested in cloud architecture, software architecture, and machine learning modeling. And I'm also open to internship and work opportunities.
Hey everyone, I'm Daniel Matthews. I'm also a first year data science major. I'm interested in machine learning and applied analytics, and I'm currently a data science intern at the Data Science Alliance.
Hello, I'm Savanjan. I'm a first year data science major, and I'm also open to internships and research this summer. CarbinWatcher is an AI-powered intelligent waste management solution. It's designed to reduce contamination across different bins across cities to prevent waste from being sorted incorrectly, which causes millions of tons of CO2 emissions a year.
So what is the problem statement? Recycling contamination is a much larger issue than most people realize. Around 25 to 30 million metric tons of CO2 emissions are linked to improper sorting annually. For example, putting recycling in landfill. Most current recycling systems rely heavily on human judgment and confusing signage. And even people trying to recycle correctly often contaminate waste streams accidentally.
Okay, so when researching this issue, we looked directly at UCSD's Zero Waste Plan, and UCSD spends nearly $1 million annually on waste hauling, while its diversion rate has dropped from 55% to around 35%, far below the goal of 90%. The university also lost recycling rebates because of contamination, and no large-scale waste audit has been done since 2011.
So CarbinWatcher is a climate-focused smart bin system that uses computer vision and AI image processing to classify waste in real time and stream actionable sustainability data to a live cloud dashboard. And our goal is to turn every item thrown away into a step towards campus-wide zero waste. And now we wanted to show a little demo of our product.
Okay. Okay, so you can see here, so when you present the momentum sensor, it tells us which bin to place the item. For example, this can is being told to put in recycle.
We're having a hard time catching your audio.
On the other.
Are you able to hear us?
I think he might be far away from the speaker
Okay.
or the mic.
Are you able to see the demo in the camera?
We can see the demo screenshot, yes.
And are you also able to see the screen share as well?
Oh, yes, it's small, but that's fine.
So I'll just link here. I know it's a little bit difficult to see, but the model is able to tell us where different kinds of waste should be classified. For example, this can here is being detected by a webcam on our board here, and the model tells us that according to laws in San Diego County, that this can should be recycled. The model can detect many different things. For example, this apple here is compost, and it helps students automatically make decisions on what bin they should place trash into. This applies to a lot of end scenarios as well. For example, contaminated plates and dining halls need to be landfilled rather than composted. And these errors compound into big carbon states.
And as you can see on the dashboard that we are also screen sharing, whenever we scan the aluminum soda can or the apple, a new item populates and it's filtered into a certain category. So the four categories that we have are compost, recycling, e-waste, and trash. And then this is directly used with we use a volume estimator that estimates the amount of volume in the object and translates that into centimeters cubed of CO2 emissions, as well as the pounds of kilograms of waste.
We then used a machine learning model to translate what seems to be just a big number into actionable insights. For example, from the waste that we scanned in, we can see that 44 trees per year have been planted in a carbon equivalent, as well as 75 cars per day in an average mileage situation.
So here's how the hardware works on the bin. We use an ultrasonic sensor to detect when an object comes close to the bin. When the sensor detects there's an object, the camera takes a picture and sends it to our servers, where a SIG LP model classifies what bin the object should go into. This protects privacy of our users because the camera is not always on and cannot constantly be monitoring things. And the images, once the inference is made on the AI model, are immediately deleted to further protect privacy. This is done so that if someone throws away things with sensitive information like a tax document or a credit card, that this data is not being exposed to the public.
Now for the cloud architecture. So what's going on is when the camera scans something, it's going to it's going to go to the cloud, it's going to send a request to our laptop, which will then parse the information which the camera scanned with the model, and then that will go through AWS IoT Core, which will take an MQTT request and then forward that and route it to an Amazon DynamoDB table. From there, the Amazon DynamoDB table has an IAM policy on it, which will allow our front end, which is the live application that you saw, to scan the table and populate the information, as well as perform other metrics, which we use to calculate things such as the trees and the cars off the road per year, as well as categorize each item of waste into the particular category and update that accordingly on the table.
One main reason that we wanted to use cloud when designing our infrastructure is that with the use of cloud, we can realistically scale from a single prototype as of right now into a campus-wide or even a city-wide deployment.
By scaling to a citywide deployment, we provide people who are interested to bringing policy change with information that can lead to actionable outcome. If we know what are major waste contributors in different parts of the city and what waste is misclassified most often, we can allow policy change to solve these problems.
Ultimately, CarbinWatcher is about transforming waste systems from passive infrastructure to intelligent sustainability systems.
Thank you so much for listening to us. We hope, do you have any questions for us?
Excellent. I don't see any questions entered, but I have a quick question. Just briefly, you mentioned that there's a SIG LP model used. Could you just do a 2-minute or 1-minute summary of that?
So SIG RLP is a model that is essentially trained to correlate different pieces of text to images. The model learns to map words into a vector space and similarly map pictures into a vector space in such a way that words and pictures that have similar meaning align closely. So how that helps us is, let's say that we calculate what the answer should be or what the vector should be for an apple. Then when our camera takes a picture, the model converts that picture into a similar vector, which will line up very closely with a vector that means apple. That's how the model knows that's how the model understands meaning. And the reason that this is a lot better than using a traditional vision language model like Gemma or Llama is that it's a lot faster. Those models are designed to do much larger reasoning tasks as well as a much more nuanced classification, which adds a lot of overhead. We wanted the system to be as live as possible. We want it to be that a student can just walk up to the camera with whatever object they have in hand and the right bin opens immediately. So this model gave us the fastest latency and for the best possible accuracy.
Adding on to Omkar's point, our next steps by using this model were to actually implement this on UCSD's campus. So using the bins that we have around campus, we were looking to not only be able to detect what trash or what waste classification the user is holding, but also open up the bin for them so that if they're holding recycling, only the recycling bin opens. And since the trash cans are actually solar powered, we would have a very easy implementation with the charging of our model.
Plus, since we're able to estimate the volume of the trash going into the can, and we know the volume of the bin, we can notify people when certain bins get full so that people are not throwing away trash in the wrong place just because a bin is full.
And the reason we use this with the cloud architecture is because we intend to have multiple trash cans, possibly thousands of trash cans, that would all aggregate different endpoints where they're sending data into a unified database. And then from that database, we would continue the front end and further analytics, which we can show to governments and cities as well, to track trash on a larger scale that isn't trackable.
For example, if one specific item was misclassified a lot, we could specifically present that and show that this item is contributing a lot to carbon waste because of its misclassification.
Excellent. What a fantastic application. I could see this being used also with government organizations, amusement parks, sporting events, corporate campuses. Really fantastic. You're solving a real problem that we all face every day. Thank you, Team CarbinWatcher. Our next project explores AI in education and personalized learning. Nora and team will present DataLingo, which is a browser-based learning platform designed to transform the traditional textbooks into adaptive educational experiences. What makes this especially interesting to me is the project's emphasis on grounded AI workflows, constraining responses to verified course content that improves accuracy, reduces hallucinations, and creates a more trustworthy learning environment for students or anyone learning. So Nora, over to you and team for a brief team introduction and to DataLingo.
Thank you so much, Sandra. I really appreciate it. Hi, everyone. My name is Nora Krentian. I am a graduating data science major with 2 minors in math and economics, and I'll be working as a data scientist once I graduate.
Hi, I'm Ilani. I'm also graduating next month in bioengineering with a specialization in biotechnology. And throughout the school year, I've been working part-time as a product manager at Mendel Bio, which is a SaaS platform also in the AI space, optimizing protein expression. Thank you for having me.
Hi, I'm Natasha. I'm also going to be graduating this year. I'm a data science major, and I'm currently a data science intern team lead at A-Round Entertainment, which specializes in leveraging ML models to make live forecast venue predictions.
Awesome. And I'm going to go ahead and share my screen so that we can go through the presentation.
All right. Thank you, Nora. And thank you to Sandra and Brian for putting on this entire webinar. Really appreciate it. So I'll dive straight in. Hi, everyone. I'm Natasha, and this is DataLingo. It's a web app that teaches beginners the fundamentals of data science through gamified lessons and a built-in AI tutor. So learning feels like less of a textbook read-through and more something you actually want to come back to. DataLingo actually started as an 8-person capstone project here at UCSD, our senior capstone, but Nora, Ilani, and I saw the potential in the project, and we wanted to further expand on the work that we've already done throughout our 2 quarters working on this. So the overarching problem our product solves is one I'm sure many of you have experienced firsthand, and that's the struggle of breaking into a technical domain as a complete beginner. Before beginners even touch real data or write a line of code, they're probably already wrestling with terminal errors and complicated environment setup. So that friction is the first thing that students encounter. And for a lot of beginners, it's enough to lower or even kill motivation to learn before they even start coding. Now, of course, there are plenty of beginner-friendly learning platforms online, but most of them are just static pages with static feedback. You read a lesson, maybe, you take a quiz, and if you're stuck, you're kind of on your own. Sometimes students don't even receive feedback, and so that can reinforce incorrect learning techniques or just incorrect thinking. Nowadays, I'm sure there's a problem you're all aware about. Students are turning to popular LLMs like ChatGPT, Gemini, Claude, etc. for help. And even with the constant advancements made in the field, AI still hallucinates. It confidently gives people answers that are flat out wrong or completely irrelevant to what their course is actually teaching. So now I'm going to hand things over to Nora, who will show you a demo of our web app, DataLingo, and how it addresses all of these problems just mentioned.
Awesome. Thank you so much, Natasha. So let's go ahead and go to our actual web app. This is a working web app that anyone can make an account on and start playing around with. So I already have an account, so I'm going to go ahead and sign in. And if you don't, you would sign up. And once we get to the first page, the first thing you'll see is this separation of levels. And essentially what we did is we scraped an open source data science textbook that is used in DSC 10, the Intro to Data Science course here at UCSD. And the levels are just split up by difficulty of topic, and within each of the levels, we have our topics. So I'm currently on the first topic, and you'll open it up and see lessons. So I'm on the 7th one, and the first thing you'll see when you go into the lesson is this text. And this text is straight from the textbook, and part of the reason why we split up the textbook in the first place was because reading a textbook can sometimes be very overwhelming. So splitting it up this way can provide a shorter segment of text for the user to read through, so they'll still get the same information and feel less overwhelmed. So I'm going to go ahead and go into the quiz. I'm on the final question here, actually, of this lesson. I'm going to go ahead and initialize the tutor. But before we get to that, let's look at our gamification features. So first, we have a streak here, similar to Duolingo. The number of consecutive days that you interact with the app, the number will increment by 1. We also have our gems here, which counts the number of questions you've gotten correct throughout the whole level. And we can see we have a total of 232 questions that we have generated in just this one level. We also have our progress bar here, which just shows our progress on the questions in this specific lesson. We have our question that was generated, which I'll speak about later. We have our category and our difficulty level of this question, which was actually generated through our pipelines. And we have our standard multiple choice structure. So let's move on to the tutor. And we can see here that we have some pre-written questions. So if a user doesn't want to type in their questions, they can easily select one of these options, and the tutor will respond with an answer specific to this question and based only on the textbook that we feed it. So it's very specialized. Let's say I go ahead and click an answer and I get it incorrect. We see here that there is another option that also pops up, another pre-written one that we can choose to ask the tutor, why is this wrong? And let's say this is the correct answer, I believe. Let's say I choose the correct one. We get the confetti, which simulates what you see in Canvas, which is what most students use once they submit a assignment. And the great thing is that your history is saved once you move on to the next question. So my lesson is actually done here. So I'm going to go back. I finished this entire topic, and you can continue to move on to the next one if you'd like. So moving back to the slides, let's talk a little bit about how we generated this data. So first, we scraped the open source textbook, as I mentioned, and our main goal was to prevent hallucinations when it came to generating these questions. And this was a big challenge that we faced, but we were able to work through it and really generate a solid set of 232 questions, as you saw, just for one level from this simple pipeline. So we first started off by cleaning the data, and then we actually followed the advice of a research paper that did also test this answer generation and then question generation workflow. So essentially what is happening is first we are passing our data through a prompt of the GPT that's getting passed into the GPT-4 model, and we're asking it to generate answers based off of our data. And then taking those answers, we're passing it through another call here, our question generation call, and asking it to generate questions based off of those answers. So this helps prevent hallucinations and keeps our question answer pairs consistent throughout. Now, a challenge we faced with this is the overwhelming amount of data that we were originally passing into our calls. We realized the more data you pass in, the AI tends to either just terminate or give not so consistent responses. So we learned to add pauses and breaks in between the batches that flow in order to make sure that there is this consistent and minimize the overhead that's being passed through the LLM. So we did that within each of the calls and also between the two steps. Another thing a challenge that we faced was the formatting. So we wanted our data to be returned in a very specific format that we can use to display on our front end. And one thing we noticed is that the LLM does do a good job at formatting, but only if you prompt it really well. So it took us a lot of trial and error with our prompts to make sure that the formatting is well and the LLM understands to return that. And then just cleaning that and saving it to our repository, and then passing that data through another pipeline that we created to structure these question answer pairs into MCQ style questions. So we face similar challenges here with the overload of data and the prompting and formatting, and we used the same techniques, and it ended up working really well, and we generated all of those questions. And as we sifted through them, and they were pretty consistent and well thought out by this model. And for both pipelines, we are using GPT-4, which was the model that was proven to do the best in that research paper that we read. So let's move on to the grounded AI assistant. So this was one of the main goals with this app, was to create your own personal tutor. And the great thing about this tutor is that you have this guided and flexible interaction as a user. So we have these question endpoints here that the user can easily select and pass through the tutor and get these answers back. That really does help solidify understanding and provide more context to help them answer the questions without actually providing the right answer. And we can definitely add more, and that's something we'll work on in the future. And then we also, one thing that's great about this assistant is the efficient topic level indexing. So a challenge that I mentioned earlier that we faced was that overflow of information being passed in. That's not only costly in terms of token usage, but also just takes a really long time. So originally what we were doing with this tutor was we were passing all of the textbook data all at once. And that took forever. You can imagine that every time you ask a question to the tutor, you're feeding in all that data every single time. And so it took a while for the tutor to respond. It used up our tokens, and it was just not very efficient. So we decided to go with a topic level indexing. If you remember, the way we split up our data was by level, topic, and then lesson. So once you're on a specific topic, everything within that topic will be passed into the tutor, and it will only answer questions based off of that information. So this leads to quicker response time and also a more specialized answer. Also, our AI assistant is very modular and scalable by design. What this means is that you can theoretically pass through any sort of data and information that you have on a specific subject, and the tutor can really learn that material and answer your questions based only on that material that you pass in. It's also scalable in that you can with AI growing and changing, you can choose any model that you'd like and have it be up to date with the technology today. One thing that I forgot to mention earlier in the demo was that we're also tracking data by the usage of the users. And the data we're tracking is how much time they spend per question, their attempts, their scores, and all this information that will later be used to build even more features. So I'll pass it on to Elaine to speak about future directions.
So where are we headed? Right now, DataLingo is built around the Data 8 textbook, but we want to expand our pipeline. The goal is to accept PDFs where anyone can upload their course material and get the same experience. So whether you're studying for a math or a law class, the pipeline works. We're also targeting standardized test prep. Think SAT, MCAT, LSAT, and GRE. These are high-stakes, dense material with a huge audience, and our tool is exactly the kind of thing people are looking for. Then there's specialized content. Think upper division engineering or niche graduate courses, where there's genuinely nothing but the textbook and lectures to help you. Your professor is the only one in the world that is covering this topic. That's exactly where we want to help. We're also using that data to add an analytics dashboard, giving students and instructors a real view into how mastery is building over time, not just whether you got a question right or wrong. We are not only looking to target students, but to expand to the entire classroom by creating live quizzes. AI generates the questions on the fly, so teachers can run this in class, which is the bigger point. Instead of students using AI to get around doing the work, we're bringing it into the classroom to enhance learning. This would serve for class practice and also give the teacher metrics on how prepared students are for a real test. Lastly, we are building out an integrated coding environment. So instead of just reading about how something works, you can actually write the code right there. There's no setup, no switching between tools, just focusing on the language learning and problem-solving skills themselves. Thank you so much for listening. Feel free to reach out to any of us if you have any questions, follow-ups, or if you're looking for the link to try the app. Thank you.
Thank you so much. I really appreciate that. What a fantastic scalable system. And we're going to, I don't have any questions in here. I have some, but I'm going to move on in interest of time. And we do want to commend all three of you for graduating. A little early congratulations, and very promising for the other students. And that all of you have positions lined up. So that's amazing. Congratulations. And we will move on to the next group. Our next project focuses on environmental monitoring and conservation through AI. So Vedant will present Invasive Watch, which is an AI-powered invasive species tracking platform that combines drone imagery, geospatial data, and machine learning to help conservationists identify ecological threats earlier and at greater scale. So this project addresses a multi-billion-dollar environmental challenge, and it demonstrates how AI can support field research, monitoring, and resource prioritization in ways that just would be too difficult to achieve manually. So with that, Vedant, over to you for a brief introduction and Invasive Watch.
All right. Hi, everyone. I'm Vedant. I'm a third-year data science major at UCSD. I mostly dabble around with AI ML a lot. I've also previously interned with PwC, where I worked with MCP and multi-agents and agentic AI. First of all, I feel really honored to present before you guys, so thanks for being here. Yeah, let's dive right into the presentation. All right. So this is Invasive Species Tracker. It is basically, the problem it solves is real, the scale is global, and the AI pipeline behind it is something I'm generally proud of. So just to give a little bit of background, what exactly are invasive species? So invasive species are species that are non-native to an ecosystem and whose introduction can negatively impact the life of plants and animals in that environment. So they basically spread through human activities, outcompete native species for food, or have no predators in the new region. The result of that, it leads to reduction in biodiversity and leads to environmental damage, disease, and stress. And just to put some numbers behind why this exactly matters, invasive species cost the global economy about $423 billion every single year. They're responsible for 60% of documented plants and animal extinction, and almost 85% of invasive species impact on native system is negative. So they are one of the leading drivers of global biodiversity loss. Land managers, conservationists, and researchers often lack accessible tools to quickly assess which species pose the highest risk. And that is exactly where we come in. So what exactly have we built? The main product is an AI-powered biosecurity platform. You can click at any point on Earth, literally anywhere, and the system uses vector similarity search and real-time climate data to rank which invasive species could establish there next. So it has a few main components. One of them is the AI risk scanner. It uses FAISS vector search, which is basically the Facebook AI similarity search open source library by Meta, which indexes all our observations and stacks them up on the basis of similarity. And there's also species intelligence, basically data about each of the species, which we have pulled from iNaturalist, Wikipedia, and Truffle API. There's a live heat map, which basically shows the iNaturalist observation density overlaid on Mapbox. And we have also done research case studies on some of the prominent areas impacted by invasive species like Hawaii and New Zealand. So just to talk about stakeholder benefits, about what kind of organizations can it really benefit? For government agencies like USDA, EPA, national parks, this tool gives them a predictive signal that they don't currently have. Instead of reacting to invasion reports, they can proactively allocate resources to regions that are model flags as high risk before a species establishes. Moreover, even for the general public, like you could be a plant enthusiast, a gardener, land manager, or park ranger, you can basically make invasion risk explorable and accessible. It also gives you instant location-specific threat ranking, so no manual search is needed. Talking about the project architecture, it uses, the front end is purely built on React and Vite, and we use Mapbox and OpenStreetMap for all our visualizations. It is deployed on Vercel. For our backend, it is mostly done in Python. It uses a FAISS library for all the similarity and clustering them. And we use iNaturalist and Truffle for all our data. So the backend is completely deployed on Railway, and both frontend and backend are connected via Fast API. Now, let me talk a little about the data, because this is where a lot of hard work happened. We started with over 400,000 of raw plant data from the Truffle Botanical API. And after cleaning and filtering out like empty shells, we landed with about 96,000 plant species to actually work with. Each species gets encoded as a 4-dimensional vector. So it takes into account the soil pH minimum, maximum, then the maximum precipitation that species can flourish in, and all those factors. The data engineering pipeline includes filtering raw truffle to the 96,000 baseline, and all the empty cells have been filled through a median imputation. Talking about the model, this is basically the core part of the project, the AI engine. And I want to spend a minute here because I think this is genuinely novel. So when you click a location on the map, two things happen simultaneously. First, we hit the OpenMeteor API to put real-time climate data for that coordinate, rainfall, temperature, and we derive the biome and estimated soil pH. So basically, how closely does the species survival profile match the target locations? And the other part is the 60% aggression score, which basically analyzes how dangerous is the species biologically. The AI penalizes rapid spreaders and plants related to known invaders. Our model was tested on, it was validated against Hawaii's documented invasive species because it is one of the biggest examples. And we obtained a recall of almost 83.4%, which was pretty impressive. The model did succeed in flagging the confirmed threats. We also cross-validated it against California's documented invasive species registry. our main results was that most high-risk species share a similar profile. They have a rapid growth rate, they survive in broad climate range, they have a flexible pH tolerance. So that was one of our major takeaway. And another was that cleaner input data is greater than model complexity. Accuracy seemed to be depending more on the data quality and not exactly the complexity of it. So the backend is not as complex as one might think of it. The future vision that I do have is establishing it as a global early warning system. So we can replace TREFL with multiple source data and integrate real-time observation feeds. I also want to evaluate prediction on future invasive species because currently we are limited only to the current species and we do not take future species which may come into existence into account. So that is another one thing which I would love to incorporate and research more about. So let us do a demo of the website. Yep. So this is the home page. As you can see, this is just a basic landing page showing what the website is about, what are the features of it. The main thing that happens is in the dashboard. So when you click on the dashboard, it shows you a big globe and you can go into any area in the world. I can choose something like, let's say, LA. Once I click on LA, if you see on the top right corner, it's showing the coordinates of the region I've clicked at. It scans the selected location and analyzes the species and observations of that region. Here, when I clicked there, it showed me the rainfall and the pH of the area that I chose, and shows me there are about 336 high-risk invasive species, 8,000 moderate, and about 69,000 low-risk species. What this means is that there are close to 336 species which, if brought to LA, could pose a hazard to the actual species, the native species that do exist there. So I can click on this, on the high-risk species. It gives me a list of the ones. You can gain more information about them by clicking on them. Like I clicked on this one. It shows its common name, which is a yellow sweet clover. It gives a story behind it. It shows the percentage risk it portrays. It also shows the growth rate. It is rapid growing, the pH range that is suitable for it, and also the native regions it is found in. So mostly found in Afghanistan, Albania, Altai, Austria, and 39 more places. So all of them are alphabetically arranged. Here I chose to click randomly, but you can also enter a zip code or you can search for a particular species as well. That was the main dashboard. We have also done some case studies. Like for instance, this is one of the biggest example for Hawaii, because Hawaii has more than 8,000 invasive species. And because of that, it has led to the extinction of almost 71 native birds which were native to Hawaii, which no longer exist. The land compromised has also been about 47%. So over here, it's just a heat map. Over the years, the red marks are showing the growth of invasive species in those particular regions. All of this data is pulled from TREFL API and iNaturalist. So as you can see, the growth of invasive species over the years. They have also done another similar study on New Zealand, because that is another place which was massively impacted by invasive species. Possum population was never actually native to New Zealand, but because of human intervention, a lot of possum did enter into New Zealand, which led to extinction of a lot of the native species that existed there. There are like further some more studies. There's also a graph showing how the growth of predators in New Zealand led to decline of native birds, which also includes the national bird of New Zealand, kiwi. So these are just some more statistics about it. And the only point of the case study was to show how impactful invasive species have been in affecting the biodiversity and ecosystem of that environment. So yeah, that was pretty much all for me. Let me know if you guys have any questions. You can reach out to me on the following places. And yeah, thank you.
Excellent. Thank you so much, Vedant. That is fascinating. I do have a question, and if we have time at the end, we'll get to it. I do want to be sensitive to time, and we will hand it over to the next team. That is a fantastic application. I really appreciate you sharing that with us today. All right. Our final presentation explores one of the most interesting emerging areas in AI today, multi-agent systems and behavioral simulation. Daniel and team will present Agent Market Sim, which is a platform that ingests breaking news headlines and then rapidly simulates market reactions due to dozens of AI agents with different personas, biases, decision-making patterns. So beyond finance, this project raises some pretty fascinating questions about how AI systems could eventually model human behavior, sentiment, group dynamics, and do that at scale. So Daniel, over to you and team for a brief introduction and Agent Market Sim. Daniel, with us?
Yeah. Let me just share my screen. Is it all visible?
Yeah.
It is.
Okay.
Hi, everyone. Thank you, Sandra, for the amazing intro. My name is Parth. I'm a CS major, and along with my teammates.
Yeah. I'm Daniel. I'm a data science major.
Yeah, and I'm Turkey, and I'm also a data science major.
We will be talking about a project, Agent Market Sim. Agent Market Sim is a platform that lets you simulate reactions to financial news before the market fully prices information. Financial markets move incredibly fast. Every day, traders are met with informations like news, tweets, and so on, and they have to act on it fast. So the question is always the same. How does this information affect my stock portfolio? And will my prices move up or down? Research from the National Bureau of Economic Research found that relevant news often causes immediate price jumps. But while markets react quickly, existing models still struggle to explain why reactions happen differently across multiple investors in different sectors. The missing piece is modeling human behavior at scale. Thought about it more than 15 seconds? Too late. If you don't act fast, you lose the opportunity to make money off of the new information. Now imagine you had a platform that ingests the latest news, headlines, all in under 15 seconds. It can tell you how the market will move, and instead of one AI making one prediction, Agent Market Sim creates many distinct agents, each with different biases, goals, risk tolerance, and decision-making styles. Agent Market Sim spawns up to 100 AI agents in parallel to simulate how the market will react to the latest headlines with respect to your stock portfolio, all under 15 seconds.
So how does our product actually work? So when a piece of news drops, we deploy 100 plus distinct AI agent personas. For example, here, an optimist, a pessimist, a crypto investor, and so on. And each one reads the same headline through its own lens and perspective and returns a sentiment score from -1 to 1. So you can see it here. The optimist, for example, is at +1, the fundamentals trade at 0.4, and so on. We aggregate those numbers into a single number, and that's our model's view of the news, and we use that to produce an updated market price. So the key idea is diversity. Markets in real life are made out of disagreeing people, and our simulation tries to mirror that, which is society. So for example, let's say we are a trader of prediction markets on Kalshi, and right now the market's pricing Fed maintains rate at 97%, 25 bips at 3%, hike at 2%. You can see those in these three lines, the green, blue, and orange. But if you look at the history though, back in September, those probabilities were essentially flipped. They moved on sharply, news events through January, March, and May. And each of those jumps you see there is the market repricing that incoming information. And that's the gap we're trying to exploit between the moment the news hits and the moment the market finishes reacting. There's a window. And our product is trying to estimate where the price should be before the market reacts. And that would help you choose whether to buy, sell, or hold. So in the background, our product ingests every latest news headline and uses AI to decide how each one relates to a specific prediction markets you care about. And that's what the graph on the left represents. And here, for example, we zoom into a specific market, which is the same market we talked about previously. And it shows these headlines and how relevant they are to each headline to the actual market with a strength weight. So we then spawn 100 plus AI agents in parallel, which is key to keeping the simulation fast. And each agent has a different persona or bias. So they interpret the same headlines differently. For this market, every persona reads the linked headlines, produce sentiment score. We have the bar chart on the left and the detailed table on the right. And notice that they disagree, and that's the point, because we don't want to take an oversimplistic view of giving an offer or confident answer. We want AI agents to simulate how people in real life do, which is having their own biases and disagreeing. And we basically take all of these means as our aggregate signal. So, as I said, we aggregate these sentiments to produce an updated price/probability, and this theoretically will give you an edge in the market if you act fast enough. So here we can see that the sentiment is at 0.259, and we convert that to a model probability, which is 75.9, and the current market is saying 44%. We subtract that and we call that an edge. So that means our market is our model thinks that we are dramatically underpricing the outcome. So it says that you should buy, and that would give you the best chance to getting a profit.
So as an aside, there is a broader problem in that AI doesn't necessarily think like individual humans. So individual humans usually have cognitive biases like confirmation bias or loss aversion or gambler's fallacy. And meanwhile, each individual human also has many different lived experiences, different education levels, basically like all different personalities. So it's actually pretty hard to try to get an AI agent to accurately simulate an individual human. We were able to do it using prompt engineering and defining pretty strict roles and pretty strict, reaction, like what kind of reactions each role should have. But ideally, we would want a more, broader, more general kind of way to have an LLM accurately model how a human might behave. So, for example, if I ask 100 different people if this glass is half full and half empty, I would get answers. I would expect, I don't know, maybe a 60-40 split or something like that. But if you ask one LLM if the glass is half full or half empty, it'll almost always answer the same unless you specifically tell it to, hey, you should be pessimist, hey, you should be optimist. And this works for very simple examples like this glass half full, half empty situation. But if you had more complex situations, if you had more complex hypothetical situations that you give an LLM, you would probably struggle to give the LLM an accurate description of how it should react. And the LLM itself would also have difficulty trying to actually simulate how an individual human might behave. But theoretically, if we could instill human cognitive biases into LLMs and give them unique personas, and there's quite a bit of research going into this. I talked to a professor at UCSD last week who was trying to do this using a bunch of different techniques. But theoretically, if we could do that, then experiments and simulations that used to require human subjects, for example, social experiments or behavioral economics or consumer analytics or focus group interviews like in industry, all of these could theoretically be simulated with AI. All of these kinds of social experiments are pretty expensive in time and effort to do because usually you need to gather a bunch of human subjects and you even need to give them monetary incentives to even want to participate in such a study in the first place. But theoretically, if we could get an AI to accurately simulate how a human behaves, then we don't even need to go through all the time and effort of gathering human subjects. We could simulate or approximate the result of the experiment using AI agents. But there is also a dystopian future I see with this, I guess. I could imagine that if we get good enough at making LLMs behave like an individual human, big tech companies could try making AI copies of you using your data, and they could use the AI copy of you to do their own social experiments, like trying to find out if you would buy a certain product or click on an ad or like this post. In a way, big tech companies are already doing this with their own recommender systems. So making a complete AI model of you would be like a huge step up. But yeah, thank you. And I think we still have some time or a bit of time. I just wanted to show what our app actually looks like. So yeah, here it is. We have kind of list of markets over here and market probabilities and whatever. And then we have a market drill down here where all the AI, so this part basically uses heuristics, simple natural language processing. But over here is where we spawn like the up to 100 AI agents to react to the news and then give their own, sentiments. And that kind of gets aggregated into a new model probability. And we're kind of out of time, so I'll end it at that.
All right.
Thank you for listening.
Thank you. Thank you to all the teams that made time during midterms to be here. Just a quick reminder, we've got June, July events coming up. In the follow-up email that you'll receive early next week, you'll be getting links to this so you can register, or you can scan the QR code here and register. And with that, we thank you so much. Thanks again to the students and to all of you for your attention and time.